Okay, let's look at another example. This is an interesting one on how you can make a box from, say, a sheet of cardboard and of different volumes. So you're trying to make an open rectangular box from an 8 by 15 inch piece of cardboard by cutting squares from the corners and folding up the sides. What are the dimensions of the box of largest volume? Okay, so we're trying to maximize volume V. All right, so let's get a picture of what we're trying to do here. Well, let's just think a box. So this is an open top. All right, and what we'd be saying is really that we have some length, some width, and some height. Let's just start with that, okay? And the volume is then just going to be the length times the width times the height. But how are we getting these? Okay, so what we're doing is we're actually taking a rectangle sheet, all right, and we're going to cut out squares from each corner. All right, and this is originally 8 by 15. And by cutting out these squares, so they're squares and we get to choose how to cut them out. So let's say they're x, they're all x by x. They have to be the same. Okay, so when you bring up those flaps, then you'll make an open box. All right, so what I want to do here then is I want to figure out what are the dimensions of the box that would result when you do this. Well, on the side here where I have 8, this portion here is going to end up being this here, and that's going to be the width, okay? And that's just going to be 8, and then I have to take away the x's on each side, so 8 minus 2x. All right, so the width is 8 minus 2x, and the length over here is just going to be 15, also minus 2x when I get rid of those two sides. So the length is 15 minus 2x, and the height, well, that's actually going to be, the height is going to be this x edge, because when I fold it up, that's going to be the height. Okay, so that actually gives me that my volume is 15 minus 2x times 8 minus 2x times x. And what I see there is actually I started with 3 variables, L, W, and H, and I ended up just with x, because these were really all the constraints in here. I didn't sort of identify them as constraints, but they work their way to a 1 variable function here. And if I multiply all that out, I'll get 120x minus 46x squared plus 4x cubed. All right, and that's my box that I'm looking for. That's my volume of my box, depending on what I choose the cuts to be for x. So, are there any restrictions? Well, obviously I need all these sides to be some positive value. So if I take the x, well, that doesn't sort of restrict me. It just says anywhere from 0, bigger than 0 to infinity. But I can't make x too big, because I can't let the side 8 minus 2x get to 0. That would get to 0 when x is 4, so I can't get to 4, so I need a domain of really 0 to 4. So I just want to maximize v of x is 120x minus 46x squared plus 4x cubed on 0, 4. Derivative. So 120 minus 9x plus 12x squared. All right, I could take out a 4 and rearrange this a little bit. So it's 3x squared minus 23x plus 30. That's 4 times 3x minus 5 times x minus 6. If we factor that, okay. And then we're looking, where is v prime 0? Where is v prime undefined? Well, it's obviously 0 if we have x is 5/3 or x is 6. And it's not undefined anywhere. But you know, I'm actually going to get rid of x is 6 because it's not on my interval there. So that's not going to be considered. Okay, so we go to our chart from 0 to 4 with 5/3 in there. So let's just put that there. So this is v prime. So if I'll go back to v prime, here's v prime in here. So if I put in, say, 1, I would get negative times negative, I would get positive. If I put in, say, 3, I'd get positive times negative, I get negative, meaning that v was increasing here, v is decreasing there, and I top out there, giving me a relative min here at 5/3 something. And again, because it was increasing all the time before and decreasing all the time after, this is a max, not a min, an absolute max. So what I found was that I should take x to be 5/3, and then what were we asking for? What are the dimensions of the box of largest? So that was the height. The width was 8 minus 2x, or in other words, 8 minus 10/3, which is going to be 14/3. And the length was 15 minus 2x, or 15 minus 10/3. And that is going to be 35/3. Telling us that the dimensions should be 35/3 by 14/3 by 5/3. All right, so in particular, this x value, that's the cut you should make, 5/3, to get the box of largest volume.